about irrational numbers. So irrational numbers are simply numbers that cannot be expressed as fractions, meaning that they cannot be expressed in this form where we have a as the numerator and b as the denominator. Unlike irrational numbers, they can be expressed in this form. So irrational numbers are like the opposite of rational numbers. If you know what rational numbers are, then you also know what irrational numbers are. So for instance, let's say 1 over 2. 1 over 2 is a rational number because we have expressed it in this form. So now, some examples of the most commonly used irrational numbers are square root of 2, square root of 2, square root of 3, square root of 5, square root of 6, square root of 7, and square root of 10. Okay, so now you might ask, now why have I skipped maybe square root of for instance 4? When you simplify 4 further, it will give us 2, right? 2 can be expressed as a fraction in many forms. It can be written as 2 over 1. It can be written as 4 over 2. It will still give us 2. So there are a lot of ways of expressing these other numbers into fractions. But unlike these numbers cannot be expressed in fractional form. But they can be left in decimal form, but it's not always necessarily that a number that has been left in decimal form can also be expressed in fractional form. It is not all the numbers. For instance, if we were to write, let's say the square root of 2 into decimal form, it is going to be 1.4, 1.4, 213, 562, something like this. So now, if you want, go and use that method that I've taught on rational numbers, the way of converting from decimal to fraction. You are going to figure out that it won't give you that fraction that is going to give you exactly the same number here. It is not going to give you a fraction. Yes, so that is why they are called irrational numbers. So now, in this video, we will be talking about how to prove that certain numbers are irrational. We are going to solve some questions from the tutorial sheet. The questions which they always bring, which they can never go beyond. They just revolve around the same questions. So once you know how to solve these questions, it will mean that you can never fail to answer any question under this subtopic, any question involving you to prove that a certain number or certain numbers are irrational. So we'll be using what is called proving by contradiction. That is the name of the method that is used. We'll be proving by contradiction method. So now, by just hearing that contradiction method, by just hearing this word contradiction, to contradict, it means that you go against something that has been claimed to be true. Okay, it's like you go against a statement that no, this is not true. Exactly. So now they'll be giving us some numbers. They'll give you some numbers and they'll tell you to prove that they are irrational. So we are going, since they want us to prove that they are irrational, it means that they have confirmed that they are irrational. They just want us to prove. So now, since we are contradicting, we are going to go against them that no, this is not irrational. So we are going to be assuming each number that they give that it is rational, meaning we'll be assuming that it can be left in this format, a over b. Don't worry, let me dive to the questions. We solved some questions from the tutorial sheet. So now let us solve some of the questions. Let's go with question 13 from the tutorial sheet. Question 13. Question 13. So question 13a. Question 13a. Question 1. B. 13b. Question 1. So they want us to prove that square root of 3 is an irrational number. So they already know that it is irrational. They just want you to prove it. So now, how do we prove it? So we're going to say, before you start proving, make sure that you should write that you are proving by contradicting. Your lecturer needs to see this. So you're going to say, proof by contradiction method. When it comes to answering answers on this topic, when it comes to solving these questions, you need to be writing these statements. You need to be writing these statements. The lecturer need to be seeing these. Okay, so now remember that we are contradicting, right? In them, they are claiming that it is irrational, and they want us to prove that. So now, since we are contradicting, we are going to say, no, this is not irrational. It is the opposite of irrational is rational, right? So it is rational, meaning that, remember that a rational number can be expressed in form of a over b. So we are going to say, we are going to write a statement. We are going to say, assume that is rational, meaning it can be expressed in form of a over b, where a and b are integers and b should not be equal to 0. B should not be equal to 0 when numbers are divided, because it's going to give us undefined. So now, you should be very fast when you're writing these statements. Actually, they usually consume a lot of time, so you should quickly write these statements. Then now you're going to say, now you're going to show them that 3 is equal to a over b, meaning these 3 that you're saying that it can't be expressed in form of a fraction. Now since we are contradicting, we are saying, now let's assume that it is equal to a fraction. So a and b are representing the integers that are involved in the fraction. Since we are trying to say that it is if it can be expressed in a form of a fraction. So now we are going to simplify. So you are going to say, okay, you're now going to apply now general mathematical principles. Remember, if the number that we have on this side, it is having a square root, what do? You multiply by 2 on both sides, right? So that these 2 can cancel with this square, right? So now, meaning that we are going to remain with, here we are going to have 3, we are going to have a squared and b squared. So we're going to have 3 a squared b squared you're going to cross multiply. You're going to have a squared 3b squared. Okay, so now when you reach here, by writing this, you're going to say, make sure you write these statements. Your lecturer will want to say this. You're going to say this this means that a squared, this means that a squared has a factor of 3, meaning that as a factor of 3, you write this statement, meaning that even a has a factor of 3. Okay, so now since a has a factor of 3, now we don't know what the factor of b is. We don't know what the factor of b is. So on this stage, what they do in order to find the factor of b, you're going to say let a be equal to a is equal to 3 constant where k is an integer. Where k is an integer, then now what you're going to do is that you are now going to get this and plug it where there is a. So you're going to say you're going to write a squared is equal to 3b squared. Where there is a, you simply plug 3k. So now we are going to plug 3k is equal to 3b squared. You're going to say 3k b squared. Remember, you're looking for b, right? So you're going to make b squared the subject of a formula, meaning you're going to divide through by. Oh, sorry, I forgot to include the square root. So when you plug in 3k into a, it is going to be 3k. Don't forget the squared. This is how we make mistakes. So we are going to say 3b squared. Okay, so now what answer are we going to get here? We are going to get 9k squared equal to 3b squared. Then you divide through by 3 into 9, it is 3, right? So we are going to say 3k squared is equal to b squared. So by writing this, you're simply saying that you're going to say this means that b as a factor of, going to say b as a factor of 3. Then you're going to say now, since a and b have a factor of 3, since have a factor of 3, which means that Okay, but when it comes to the grammar, it shouldn't be exactly as I'm writing, but it should be saying the same thing on each stage. Even if you can phrase it in whichever words you want, but it should be um, talking about the same thing. Even if you try to go through different books, you find that the statements are not exactly the same. Like when it comes to the grammar and the words used, they aren't exact. It's just that they want you to say these things at each stage where you reach while solving. Okay, so now remember, so here is like this. So we've just figured out that A and B, meaning that according to this this fraction that we made here, we've just figured out that A is 3 and B is what? 3. This cannot be, they cannot be expressed as fractions. Why? Because 3 is going to be divided into this one, because this is going to give us 1. And remember, we said that an irrational number is the one that cannot be expressed in form of what? In form of a fraction. So we've just proved that this is irrational. So meaning that since we were contradicting, so what we are contradicting, our contradiction was not true. So you can further say that, which means that 3 is irrational. It's irrational. Hence the contradiction. Is not true. So you just need to be writing these statements on whichever point where you reach. So A and B have a common factor, meaning that it cannot be, it cannot be expressed as a fraction. Let's look at so the same applies with the second question. On the second question, they just want you to prove that the square root of 2 is irrational. You just have to use the same method here. Using all these steps, even if it is going to give you the same form of answers. Yeah, so that is how you solve these questions. So now I want you to try out the second one. Let me now solve C. Okay, so now let us proceed. So the second question is quite tricky, as you can see the way it is phrased. So sometimes they like bringing questions like this. They'll tell you that given that the square root of 3 and 5 are irrational, show that the following are not irrational numbers. So now they want us to show that the 3, at first they want us to show that the square root of 3 plus 5 is irrational number, right? So now sometimes what they do, they will give you the number that they want you to prove that it is irrational. They'll give you that number. They'll give you the number that they want you to prove. In our case, we have been given square root of 3 plus 5 we have to prove that it is irrational, right? So now when they give you that number, they also give you that, given that, let's say here we have been given 2, but oftenly you'll be just given 1. So they'll give you something that they'll tell you that are irrational. So here what they want you to do is that they first want you to simplify whichever number you have been given until you reach a point where you are going to have either whichever they have given you, they have saying that given that it is irrational. In our case, we've been given 3 and 5, so they're saying that try to simplify the number that you've been given. You need to reach to a point where you are going to either have square root of 3 or square root of 5, and when you reach at that point, you have now to prove that it is irrational. Okay, let's solve it to make sense. So let's begin. So let's go question 1. We have been given to prove that 3 plus 5, to prove that 3 plus 5 is irrational, right? So now okay, so we are going to say proof by contradiction method. We are going to use the same contradiction method. You are going to use contradiction method. The same way we are proving, it's the same way we are going to prove this, but we are going to reach the point where we are going to have this as the subject of a formula which has been given in the question. If here we had 5, it means that we were supposed to reach to a point where we were supposed to have 5 squared as a subject of the formula. So now let's proceed. So you're going to follow the same procedure. You're going to say assume that 3 plus 5 is rational. Remember, we are contradicting. It's rational, meaning that it can be expressed in form of a over b, where a and b are integers and are integers with no common factors, Forgive the handwriting. I just want to write very quick. I have no factors, and the denominator, which is b, is not equal to 0 because we are going to get undefined. So now let's now equate to a over b. We are going to write 3 plus square root of 3 plus 5 is equal to a over b. It's equal to a over b. Okay, so now remember, in this case, when we have a square root being added to 5, and we also have something on this side, we usually take this on the other side so that we remain with what is having a square root. Then we square them, right? So now we are going to follow the same procedure, but we are not going to square them. Now I'll tell you the reason. First, let's follow the procedure. So you're going to say 3 squared is equal to a over b. When this goes this side, it's going to be negative, right? Let's leave it as a single fraction. You have to leave this as a single fraction. So let's say common denominator b. We are going to have a minus 5b. Okay, so we are going to say square root of 3 is equal to a minus 5 over b. Okay, so now the tricky question about this kind of question, when it is, remember, okay, unless we were not given either square root of 3 or 5. Now if we have been given this along with a certain irrational number, meaning that our target should be leaving it as a subject of a formula. In our case, we have already been given square root of 3, and they're saying that it is irrational. So they want us to follow the same procedure, but when we reach where that number that has been given is, and to make it the subject of a formula, like the way you did. In fact, here our goal was supposed to make it the subject of a formula. That should be your goal in this case. And if there is another number that has been given, and they are claiming that it is irrational. So now, when you reach at this point, you don't need to go further and do this and multiply by square root of 2, you square both sides. No. Now, this is where now it becomes quite tricky. So now, what do we do here? So I want you to remember that in the equation they have said that given this one is irrational, right? So now, you're going to see again this part. What do we have here? We have a fraction, right? This is a fraction. We can't divide this into this. This is not, the numerator is not divisible by what we have here. So no matter what we do, this cannot be simplified further. This part only, it can ever be a fraction. So here, what we have, remember they have said that this is irrational. They have said it. So what do we have here? Remember that if a rational number can be expressed as fractions, right? So here, what we have is, on this side, we have an irrational number, and on the other side, we have an irrational number. Now, so what is happening here is that an irrational number has been equated to a rational number. Now, is that making sense? Remember, here they are simply saying that when you equate something, it means that you are saying that what is A is equal to A. Now, is it true that an irrational number is equal to a rational number, which is false, right? So, for these types of questions, our journey just ends here. All you need to do, and all your lecturer want to see, is to write the statements. Now, the lecturer want to see these statements because you need to know that you have understood how to use the contradiction method. So now, you are going to write the statement. You are going to say, A. You are going to write whatever is on the numerator A above. You are going to write it. You are going to say A minus 5B. And we are simply assuming that what is above and below are integers. Yes, A and B can be integers. So in the B, the numerator and denominator are integers. Which means that A minus B over B is irrational. It is rational, yeah, since they are fractions, which means that this is rational. We are going to say, however, an irrational number can't be equated to a irrational number. So now then you are going to say, hence the statement above is not true. So when it comes to these statements, you should write what your lecturer will teach you. Every lecturer has his own statements that he writes. The way he phrased them, that's how you should also phrase them. Each lecturer will phrase these statements in his own grammar, and lecturers want you to write what they have taught. So you should make sure that you check out what your lecturer will teach on this topic. I mean, those are the statements that you should be writing on either the test or the exam. Yeah, but they are different, but they all talk about the same thing. All you need to do is to understand the concept. So this is how we prove it. And in case maybe you forget to write these statements, you end up losing marks. They also carry some marks. Yeah, so now even these remaining ones, I want you to try them out. You just need to do the same thing. Even for question 2, even question 2, you follow the same procedure. You take one on the other side. You're going to remain with square root of 5 as the subject of a formula, and then you are now going to quote the same statements. Even question 3, these are all the only questions that they bring on this subtopic. They don't go, and they have never gone beyond this. So once you just understand this, and there's another tricky question, I almost forgot. Maybe what we've been given, let's say maybe they gave you something like this. Let's say maybe they said 3 square root of 3 plus 5. Just say they gave you this. This one, when we reach, you also need to follow the same procedure. You get A is equal to B, but on this one, don't take this on the other side. This is where most of the students screw up. This is why they make a lot of mistakes. Don't take this on this side, since both the numbers that are on this side are having square roots. So you just square here and you square here. Then now you start now expanding. You expand until you live with either 3 or 4 as the subject of the formula. These are just basic algebra. Yeah, and then you end up somewhere like this. Then now you're going to write the same statements. So apart from this, they don't go beyond this. These are the only questions they bring. So if you know how to solve this, then you can never get any question wrong on this subtopic. Okay, this is it for this video.